Good morning. Welcome to episode 109 of the Driller Newscast, a weekly update on the news and stories impacting the construction, drilling, and water industry. I'm your host, Brock Yorty. Episode 109 completely been blown apart because as I was filming it, tornadoes hit Kalamazoo, Michigan, and Portage, Michigan, Battle Creek, many cities across the Midwest, and it's completely shifted our news schedule. So this week, we're going to talk about extreme weather preparedness and what we should be doing for our employees. And then we're going to early debut our new series, Thermal Networking, with our first guest, Kevin Austin, who started as a project manager at Triton Geothermal on, at the time, the largest thermal network project, Ball State University. This will be a two-part series. We're going to talk about what it takes to be on a big project, all of the intricacies, and then we'll continue next week with part two. Yes, we're still going to get to my European excursion into thermal networks and sharing that knowledge. We're just going to shift it to episode 111. I hope you enjoy. For this week in safety, let's talk about extreme weather emergency action plans. As I filmed this last night, and of course, there's a delay to the news in the way we have to produce everything and get it out and ready for you at 6:30 in the morning on Monday. So as I filmed this, tornado sirens went off in my hometown, Kalamazoo, Michigan, as tornadoes hit just a few miles away in Portage, Michigan. This got me thinking. So I worked in the Southeast and we planned for lightning and extreme heat, and tropical storms turning into hurricanes. Midwest drillers all across the country, we need to really adopt better extreme weather plans. We talk a lot about lightning. How many miles away is acceptable? For me, it's a hard stop at 8 miles away, especially as that storm's traveling and we have smartphone technology. Extreme heat, we're using the OSHA NIOSH extreme heat app, which is explaining to us how much water we should be consuming. Last week, when I was in the Netherlands and Belgium, it got up into the upper 70s, and that is not natural for them. They were talking extreme heat, what they should be drinking for water, preparing. So let's jump into this. OSHA and NOAA, our National Weather Service, are working together on public education efforts aimed at improving the way construction companies and people prepare and respond to severe weather. To prepare for a tornado, businesses should develop an emergency action plan. The plan should include details on suitable places to take shelter, policies to ensure all personnel are accounted for, and procedures for addressing any hazardous material that are on site. I want you to think about that as we lay out our equipment and tooling. Are we going to need to quickly tie down this job site and move out? These storms, we see them surge across our country as we did with this massive cell that hit last week. But we have to think about this. No different than when we come up off bottom as we see the bit interacting with something that we're not quite sure of before we plug a bit. We need to have these action plans in place. OSHA also recommends that individuals develop the same action plans for their families, which should have a checklist. Go to the OSHA resource pages, which offer great checklists and suggestions for this. So, what is your company's policy for big storm cells that can turn at any moment into a tornado? Obviously, we now get emergency alerts that say there is a tornado in your area, say that we're in a severe tornado warning. We need to understand the difference between a warning and a watch. And as we look at the weather and they start talking about torcons, the difference in likelihood of a torcon 1 versus a torcon 5. For all our great drilling companies that are in the Mid-Con, Kansas, Nebraska, Oklahoma, Texas, you're all saying, what are you guys talking about? We know all of this. We understand road by road as the storm's coming across. We can do better in the rest of the country as well, as more greenhouse gases are absorbed into our atmosphere and we have more water vapor that is trapped there. Our weather continues to be more wild. So, what is your extreme weather plan for lightning, for heat, and now severe thunderstorms that at any minute can turn into a tornado? Beyond that, how are we communicating with our crews? After the tornado has occurred, what steps are we taking to recover? How are we helping out? How do we get back to that job site? These are all essential questions that we need to discuss, including as we're on that job site, down power lines or obstructing the work that service crews and emergency responders are doing. Is this a day that we just shut down completely and we head home? Or we, as great construction professionals, grab that chainsaw or we start dragging brush out of the road, as we are great community members as well. On top of that, let's consider all of our employees after a big storm cell has come through, may be physically on site, but they're mentally thinking about their families and their homes. And what distractions are we causing that could get somebody hurt? And now we have emergency responders responding to a massive storm. They don't have time to get to our job site. So I challenge you right now to put together your emergency action plan, get it written into policy, and be ready to support your job site, your employee, the community, and all our families. Go out and be safe. So I'm here today to talk some geothermal, and I have a industry expert, but beyond that, industry friend that I've known since pretty much the beginning of the first big geothermal boom that happened, and that was Ball State University. Yes, there were federal buildings. There's plenty of other things going on, but man, when it was the late 2000s and Ball State got brought up, it was a big deal. And you can see that from the engineers that moved on to do lots of big stuff and drilling companies and whatnot. And so to jump right into this, I have a great expert, but also a good friend and colleague of mine, Kevin Austin. And Kevin, go ahead and introduce yourself. Thank you for coming on.
Hey, thank you, Brock. I appreciate that introduction. Sometimes it seems like you're talking about somebody else, but yeah, Ball State was just an incredible opportunity. I was working in central Indiana and had an opportunity to go on board with Ortman Drilling, who started an LLC called Triton Geothermal with two other Midwest Indiana drillers, and take on 1/3 of the Ball State project, which ultimately ended up being 1,800 boreholes, 400 foot deep, and a couple of 1-inch loops and some 0.88 grout. But great opportunity. Was hired for 6 months and stayed almost 14 years in that capacity, and just really changed the trajectory of my career from construction and project management specifically into geothermal energy. And this is what I'll do for the remainder of my career, for sure.
Well, it's fun is why we do it, right?
It is, absolutely. I agree with you 100%. Yep. We've got some great people that we get to work with in the industry, and as you well know, you were heavily involved, and you were a big part of our success on that project and your capacity as a mud engineer with Baroid. We took teams of people down to the mud school in Houston with Baroid and went through the programs. You spent weeks and months on end with us on campus, really helped us develop our mud program. So it was I think mutually beneficial, but it was uh, just a fantastic opportunity.
This is a great time to just shout out the Triton Geothermal folks and Rick Ortman at the time, because heck, I was a young mud engineer. Heck,
Hmm.
you were a brand new project manager to the
Yeah,
first phase of one of the biggest geothermal projects done.
absolutely. Rick Ortman with Ortman Drilling and the, um, the folks at Moss Well Drilling out of Galveston, Indiana, and also Dilton Brothers Drilling, Wayne and Don Finley out of Lafayette, Indiana. So the three of those companies came together. None of them wanted to or were large enough, I feel like, to tackle the initial 600 holes for the South Field in the time parameters that were provided. So it made sense for them to combine forces and resources. And they actually built an LLC for that project and then continued to do projects under that umbrella for a number of years after. Yep.
The first time I met you, heck, I think I was out there on a test hole, and you may not have even been part of the team yet. And a test hole happened, but the plan was 9 months, right?
Correct. Right. Originally, they estimated that each of the three drilling companies under Triton would each drill 200 holes. They thought they would be there somewhere between 6 to 9 months. And the reality was the test drilling did not reveal what the actual formations were on that particular Southfield campus. They had done test holes on other locations on campus and essentially off site and used that information to design the field. What we actually found was that there was quite a bit of unconsolidated material, sand and gravel, rocks and cobbles and things that created a greater challenge for keeping an open borehole. And the mud rotary method was selected to drill this project. So we ended up having to increase from a 5 5/8 or a nominal 6 inch hole up to a 10 inch hole and drill an additional or the first 60, 65 feet and set 7 inch temporary surface casing, which created another step in the process, more equipment, more material to be evacuated. So it was a big learning curve, I think, for everybody involved. But ultimately, with the help of yourself and there was many people involved, the various suppliers, equipment manufacturers and suppliers, Centennial Pipe, Baroid. There was, both from a grout pipe perspectives, equipment, and just the learning curve, the training that we went through, and getting the processes down.
Yeah, it was wild. I remember a discussion about air drilling and the amount of water we would produce, and that was a discussion of what would we do with all of this water, which here it is, what, 16, 17 years later, and we're still having big discussions about mud versus air and water
Mhm.
production. And I remember that first time the tanker truck showed up to pull mud and take it to, disposal site. And that was quite a challenge that nobody had thought about, just the disposal aspect.
It absolutely was. And I don't know that air rotary would have worked on that. It was this Ball State being a 660-acre campus, but it's right downtown in Muncie, Indiana, in a highly populated area with well-developed and established housing districts all around both the north and south bore fields. And there just was no place for the water to go. So mud rotary was determined to be the best method of drilling, both in terms of holding back the formation, but also holding back the groundwater that we were going to have to contend with. And that's one of the big lessons that was learned is the dealing with the cuttings and dealing with groundwater. Had the wettest spring on record. We had a massive amount of rainwater that year, and none of those things were ever addressed, in the contract. So it was a big point of contention, and there was a lot of money lost there because that was not addressed in advance. And seriously, one of the big lessons that we learned, and it changed the way that we structured future contracts from there forward. Absolutely.
Yeah, that comes right back to test holes.
Mhm.
There's things we can control and things we can't control. One of
Correct.
those being Mother Nature. And let's face it, from late 2000s to today, we just looked at the hottest March on record with a 1.68 degrees above Celsius, and we've been targeting 1.5 being the tipping point.
Right.
You see flooding and whatnot, and you're talking about extreme weather was not a buzzword. The drought in the Western United States was not a
Right.
buzzword. We weren't
Right.
considered, we weren't worried about any of that.
Correct. Climate change is certainly something that we all have to contend with and prepare for. And I think being aware of those potential issues and contingencies, or saying having a contingency plan in place. What do we? What are our steps or our methods or containment measures if we have an unusually heavy rainfall? If we've got drought conditions, if it's heavy rainfall, we're dealing with excess fluid on the job site and runoff and muddy streets and Area 5 rules and things like that. If it's a drought condition, maybe we're talking about dust suppression and things like that. So those are all factors that have to be considered before going into a large commercial project. You're on a small, light commercial residential, you're not there long enough for it to really matter. It's I think it's all relative to the size of the project. But weather is certainly a huge factor, and the formations are a huge factor. We're dealing with a material, being the earth, that no one has ever seen, no one's ever going to see it. We might be on a street where we're getting 2 to 3 holes a day and we're clicking along, and then you spend 3 days on one hole. And a lot of people outside the industry, a lot of even engineers and general contractors, they don't understand that concept. They're used to being able to put up so much board foot per day if you're hanging drywall or setting structural steel or something. But drilling in the earth is it's part art, part science, part there's a skill and there's an art to it both. It's a very different industry than anything else I'm aware of.
And I think one of the great strengths that I learned from you on this project and others is, your experience in construction outside of, production geothermal and
Mhm.
dealing with general contractors. And then,
Mhm.
you know, you get to Ball State and you have engineers, you have a general contractor, you have a university that's a client, and then you also have a neighborhood
Mhm.
and college students.
Sure.
How did you manage all of that?
I was really fortunate in my earlier career. I had spent some time in the military, and so had some structured supervision training along the way. Also had the opportunity. I was on a $1 billion plant expansion project down in Concord, North Carolina, a few years prior, and learned to deal with multiple trades and contractors, logistics, sequencing. OSHA compliance, those types of things. I think the key concept is to not let it be emotional. You have to be very diplomatic in your dealings. We had you mentioned the neighbors and the surrounding folks. We had neighbors that filed lawsuits both against Triton, against the university, against the general contractor, claiming that we cracked concrete and things like that. There was noise complaints and things of those nature. None of those ever were. They were all dismissed. None of the claims were ever settled in any way because really there was no merit to them. But you still have to deal with the surrounding community, and I think the opportunity for people to be heard is important, whether that's through some kind of public forum. On a project of that magnitude with that kind of publicity, perhaps that's something that should have been done in advance of the project to explain what they're doing and what's going to happen and the time frames and the working hours and potential for noise and things like that. But ultimately, I think through just listening to people and having a open, effective line of communication, we were able to resolve any of those potential problems. in terms of the university and the engineers and so forth. Everybody had the same goal. The problem was nobody, including the drillers, had tried to tackle a project of this magnitude. So there was a big learning curve. The contractual documents that were assembled from the general contractor were lacking, to say the least, in terms of who would be responsible for different elements like rainwater, different things like that. There were phasing requirements on the project where they would require us to work on a certain section of the bore field up into a certain date. And I think there was 5 phases on the south field alone. And that was never really articulated to any degree. And it was an expensive proposition for the drillers to continue to move equipment and rigs and water lines and things like that. And so it caused some contention. But ultimately, the job's got to get done, and you find ways to work through those. And fortunately, it never turned into anything other than maybe a couple of passionate conversations. But yeah, ultimately the job was done, and I think it was done very well.
I want to move on to production geothermal, but before we do, I can remember individuals hiding in bushes taking photos. And there was so much to do with this being the high profile project. It was pretty neat because if I remember correctly, Ball State needed to fix their coal-fired power plant.
Correct.
Or invest into, this thermal network. And we didn't call them thermal networks yet. We hadn't talked about everything that we're doing now that you're seeing, from One Java in New York to Framingham, Massachusetts, to Lowell, Massachusetts, to big universities. Not that Ball State's got Letterman and got some other pretty famous people, but seriously, when you start saying names like Princeton and Yale and Notre Dame and University of Michigan and many other big schools that have bigger campuses around much more high profile cities. I mean, New Haven, you're not going to put pumper trucks through downtown all hours of the day. Notre Dame, same thing. Hey man, we got touchdown Jesus, and you better not mess with football. And so it was a heck of a thing to watch and see completed, and I commend you. So now it's real. We're doing production geothermal across the country. We have the Inflation Production Act. You're out recruiting drillers, but you have this great insight into that first project and other projects that you've experienced, and now you share with the industry. But how do we succeed in production geothermal? Just give us your Kevin Austin, no BS advice to getting this done right.
Brock, I would think that it might be summed up in 3 words. At least that's what comes to mind initially. And those 3 words are safety, planning, and communication. And I think if you have all those elements and they are fully communicated and implemented through the project, obviously safety for the employees, the contractors that are working, for people that are adjacent to and working around the job sites, and safety. I would say that to mean environmental protection of the aquifers, environmental resources, all those things I think kind of fall into that category. So you cannot have a successful project without having a highly safe project. First and foremost, planning. I think that planning needs to be addressed, and it needs to be looked at in a concept of the entire project from start to finish. How are we going to move in? What are the phasing elements? How long is it going to take? Have we looked at weather conditions? What are the possible elements that might extend the project? What happens if we do? Hours of the day, those types of things. So you really go through all the pre-planning. Contracts are hugely important. So everyone fully understands what is their responsibility, what is their financial responsibility, what are the timelines for all these components. The scope of the project, plans and specs need to be very well not only shared, communicated, understood, and bid accordingly as part of those contract documents. And then the communication there, again, it's through the entire process, through the safety portion, through the planning portion, and it needs to be done often, and it needs to be done early, and it needs to involve everyone that is involved in the project, and keeping those three elements together and done properly, I think really sets you up for a successful project.
Thanks, Kevin. That was awesome. Part 2 will be in episode 110. And then, of course, I promise we'll get back to Brock's big European tour of thermal networks and projects that I'm really excited to share with you. There's so much that we can do in innovation. But again, think about communication and integrity and just collaborating on job sites as necessary, from a 3 or 4 or 5 hole project to a massive collaboration with multiple drill rigs and hundreds of holes. There's plenty of naysayers out there right now that do not believe that we can ramp up ground source geothermal to the necessary levels we need. And drillers, we can do it. This is a great way to diversify our business. Thanks again, Kevin. Thank you for joining us for episode 109 of the Driller Newscast. Check out thedriller.com. There's great content coming out all the time. And again, let's be smart about this extreme weather. It's popping up, but it's also big cells that are crossing our country. And we can be better at understanding when and where they're going to hit, and if our people are going to be in the path. Go out, have a great week.